In my another vector tutorial, we are doing from Cambridge Admath book, exercise 13.4, and question number 7. I'm trying to show you it's slightly different. Its initial position has been given 5 by 12 j kilometer, and tanker sails southeast with the speed of 12√2 kilometer per hour. From here we have to find the velocity vector of the tanker. So the first question we are trying to solve, we needed to draw a diagram because it's moving southeast direction. So what is the southeast direction? Say it's the center. From center, if we move to the southeast direction, then actually it is going like this. In that direction it is moving, and in that direction it is moving by making 45 degree with the y-axis and 45 degree as well with the x-axis angle, because in that corner it is moving. We know this is south and this is east in our copy. So if the value is given, let you write 12√2. By using the trigonometry we can find out these two value. So it moves to the right side as a x and it's moved to the down y. You can say like this. Let me make a relation. By Sokatwa or trigonometry, we can write x divided by 12.2, 12√2. It is actually cos 45, because x is the adjacent and 12√2 in the position of hypotenuse. So x equals to, it gives us 12√2 into cos 45, which is actually √2 by 2. So if you multiply 2 here, it gives us 6√2 into 2, which we can say 6 into 2 is 12. This is the value we got, 12. And another one, y by 12√2, which is actually sine 45. We can write from there, sine 45. So y equals to 12√2 and sine 45, it gives you √2 by 2. You may use calculator, we would get from there the same value, which we can say 12 as well. 12. So our velocity vector in that stage you can write here, because it goes in the positive direction in the x-axis, which you can write by 12i, and it goes down in the y-axis. That's why we have to use the negative sign, negative 12j. I and j is the unit vector in that particular direction. I mean x-axis and y-axis as well. This is the first part of this question. Let me move to the second part of this question, B, and it is written here, find the position vector of the tanker at 14:00 hours. It means just it started at 12. So if we move to the 14:00, I means 2 hours we have to use there. If we subtract, then we got the 2 hours. So the position vector of the tanker, its initial position is given, so we can use the formula R equals to A plus T into V. Here A is the initial position and V stands for the velocity vector, and T is time for that particular particle. So 5i plus 12j plus time is given here 2 hours, 2 into its velocity vector 12i minus 12j, because it is written 14 hours. So let you break down. 5i plus 12j plus 24i minus 24j. So we are going to add 24 plus 5, which is 29i, and 12 minus 24, which gives us minus 12j. And this is our position vector after 14:00 hour. The next question is 12 hour 45 hours. So what does it mean? 12:45, if we subtract the 12, because it's starting point, it gives us 45 minutes. So from 45 minutes is the first question. The second question we are doing, we got the time at 12:45 hours. It means that it gives us 45 minutes from the initial position. So 45 minutes, we are going to convert it the hour. We have to divide with the 60, and we got from there 3 and 4. If we divided the, so 3 by 4 hour. Then same equation you can apply to that question. R equals to A plus T into V. A initial position and V stands for the velocity vector. Initial position, it is given here 5I plus 12J, and plus time is 3 by 4 hour, and its velocity vector we got from the 12I minus 12J. Let you write it, 5I plus, we can cut out 4, 3, so it gives us, this is the 9I, and let you write the 12J, and also the second part also the minus 9J, and 9 plus 15 is 14I, 9 plus 5, sorry, and plus 12 minus 9, which is gives us 3J. And this is our final position of this vector. Hope guys you understood the way we're solving this question. Now we are in the last stage of this question. Find the position vector of the tanker 2 hours after leaving P. It's easy question because we already have all the information. I'm going to write it with that different color because I do not have enough place to show it. Anyway, it not needed huge place to show. See, here I'm going to show the final position vector. We can write A plus, this is the same formula we're going to apply, A plus TV. A is 5I plus 12J plus T into its velocity vector 12I minus 12J. So this is our answer. You can leave your answer here, or also you can write by taking the I and J common, which gives us 5 plus 12T, and another one, if we take J common, it gives us 12 minus 12T, and this is the final part of this answer. Here we wrote I and J, which is the unit vector in the x-axis and as well unit vector on the y-axis. This is the total of working of this question number 7. Thanks for watching with patience. You may see my other tutorial